May 1996. Somewhere off the coast of Norway, a gray wall of concrete rises out of a heaving sea, and it is moving. 10 tugs strain ahead of it on steel lines, throwing white water. Behind them drags the heaviest object human beings have ever transported. It is going 1 knot, and nothing on earth can stop it quickly. To understand that morning, go back 17 years. 1979. Off western Norway, drillers find gas. Not a modest pocket, but one of the largest gas accumulations ever discovered in Europe. They call the field Troll, after the creatures of Norwegian folklore. It lies beneath more than 300 meters of cold, restless water. The gas is enormous, and the problem is equally enormous. Norway wants to sell it to Europe for decades, which means a production platform that will sit in one place for a human lifetime. But the water at the site is around 300 meters deep, and the North Sea in winter is one of the most violent working environments on the planet. 2 choices: float something on the surface and moor it, replacing chains and equipment for decades, or build something that simply stands on the bottom, held down by its own weight, and let the ocean break against it. The Norwegians had already spent 20 years perfecting the second idea. The design lineage was called Con-Deep, concrete deep water, a wide cellular base sunk into the seabed, with hollow towers rising from it to carry a steel deck above the waves. The cells give buoyancy while it floats, and then hold ballast once it lands. Troll A would be the largest of the family by a wide margin. They needed somewhere to build it, and Norway's geography answered. The fjords are drowned glacial valleys, sheltered from ocean swell, yet hundreds of meters deep, right up against the shore. At Vats in Rogaland, a construction site was carved into the water's edge. The structure would be built floating, growing downward as much as upward. Construction began in 1991. First the base, a honeycomb of huge concrete cells cast in a dry dock, then floated out into deep water. From that moment, the unfinished platform never touched land again. Every further meter of concrete was poured onto a structure hanging in the sea, sinking lower as it grew heavier. The walls were built by slip forming, a ring of formwork wrapped around each shaft, jacked steadily upward while wet concrete poured in behind it and hardened below. It never stopped. Day and night, through Norwegian winters, the forms crept skyward at a pace slower than a growing fingernail, and the towers rose without a single cold joint. The quantities are hard to hold in the mind. Roughly 250,000 cubic meters of concrete went into the structure, bound together with a dense forest of reinforcing steel and post-tensioned cables. Every cubic meter had to be mixed, delivered, and placed without a break in the pour, in a fjord on a floating object. The concrete itself was engineered as carefully as any machine. High strength, low permeability, mixed to resist decades of salt water pressing in from outside. At the base, the sea would push with the weight of some 30 atmospheres. The wall had to keep that out for 70 years, with no possibility of major repair. Thousands of people worked the site across 4 years. Steel fixers tying cages in freezing rain, divers checking the submerged base, surveyors watching for the smallest tilt, because a floating tower that grows crooked cannot be straightened later. The whole structure was, in effect, a building balanced upright in the sea. Buoyancy was the invisible engineering. Air, trapped in the sealed cells, held the growing tower up. Water pumped in and out kept it level. Control the water, and you control 1,000,000 tons. Lose control of it, and you lose everything. Every pour changed the balance, and every change had to be calculated in advance. Above the base, 4 hollow shafts climbed toward the surface, each on the order of 360 meters of continuous concrete. Inside them would run pipes, cables, and lifts. From the seabed to the deck, the finished structure would measure about 472 meters, taller than the Empire State Building, antenna included. It had to survive the worst sea anyone could reasonably imagine. Engineers design offshore structures for the 100-year wave, the extreme event expected roughly once a century. In the northern North Sea, that means walls of water more than 20 meters high, arriving with the force of a slow-motion collision, again and again, all winter. While the concrete grew, the other half of the platform was being built elsewhere, the topsides. Drilling equipment, processing gear, power plant, control rooms, and living quarters for the crew. Tens of thousands of tons of steel, assembled onshore into modules and lifted together into a single deck. Then came the mating. The concrete tower was ballasted down until its shaft tops sat just above the waterline. The deck was floated over on barges and positioned above them. Water was pumped out. The tower rose, and it lifted the entire deck off the barges, the sea itself acting as the crane. Complete. The structure was a single object of almost incomprehensible mass, commonly given as around 1.2 million tons with its ballast. It floated. That is the astonishing part. Something heavier than any building ever constructed sat in the water like a cork, held up by nothing but sealed air. The move was scheduled for May, when the North Sea gives its longest calm windows. Forecasters watched the Atlantic for days. Once the tow began, there would be no turning back, no harbor to run to, and no realistic way to hold the structure against a serious storm. They waited for the weather, and then they let go of the moorings. 10 tugs took the strain. The tow ran roughly 200 kilometers from the fjord out to the field, and it took about a week. The speed was close to 1 knot, slower than a person strolling along a pier. Watching from a boat, you could barely tell it was moving at all. Underwater, most of the structure hung invisible, hundreds of meters of concrete below the surface, sweeping through the sea like the hull of an impossible ship. The route had to be surveyed for depth along its entire length. A shoal that would not trouble any vessel afloat could have destroyed this one. Every hour, the position was checked against satellite navigation. The target was not a harbor, but a patch of seabed, a few hundred meters across, chosen years earlier because the clay beneath it could carry the load. After decades of planning, the whole project came down to arriving at the right coordinates. At the field, the tugs turned the structure and held it in place while the final operation began. Seawater was pumped into the cells, deliberately, in a controlled sequence. The platform began to sink. Over hours it settled lower and lower, still perfectly upright, still watched by every instrument on board. Then, 300 meters down, it touched. Steel skirts around the base bit into the seabed and drove deep into the clay, a penetration measured in tens of meters. Water was pumped from beneath the base, pulling it down hard onto the bottom. From that moment, the platform was no longer floating. It was part of the seabed. Nothing anchors it. No piles, no chains. Troll A stands the way a mountain stands, by weight alone, its ballasted base pressing into the clay with enough force that the largest storms on record cannot slide it or tip it. The engineering trick is simply to be too heavy to move once you have arrived. With the platform fixed, drilling began through the legs and down into the reservoir. The troll gas sits in a sandstone layer beneath the seabed, and the wells reach out sideways through it for great distances. Production started that same year, and the field became a cornerstone of Norway's gas exports. The gas does not go into tankers. It goes into pipelines on the seabed, running east to a processing plant on the Norwegian coast, where liquids are separated out. From there, it enters the export network that feeds homes and factories across Europe, a continuous invisible river, flowing since 1996. As the reservoir pressure fell, the platform needed compressors to keep the gas moving, and compressors need enormous power. Instead of burning gas offshore, engineers ran high-voltage direct current cables from shore and installed huge electric drive motors on the platform. It was the first installation of its kind in the world. Life on board is ordinary and extraordinary at once. Crews arrive by helicopter, work their shifts, sleep in cabins above 300 meters of water. Inside one of the legs, a lift descends toward the seabed, taking minutes to reach the bottom. Outside in a winter gale, the whole world is white noise and gray water. Concrete was chosen because it endures. The structure was designed for a working life on the order of 70 years, with sensors watching for settlement, cracking, and corrosion. Steel would need constant protection down there. Thick, dense, well-made concrete simply sits in the salt water and waits. It holds records that may never be broken. The tallest structure ever moved by human beings. Among the heaviest objects ever transported. And unlike most records, this one was never the point. It was simply what the water depth demanded, once the decision was made to build something permanent. Somewhere out there tonight, it is standing in the dark, lights burning, gas moving through it, the sea breaking against concrete poured before many of us were born. It was floated out of a fjord at walking pace and set down on the bottom of the North Sea, and it has not moved since. It was never meant to.